Welcome to the next session on MATLAB basics. In this session, we will take up the nested loops of MATLAB. MATLAB allows to use one loop inside another loop. We will see the syntax for it. The syntax for a nested for loop statement in MATLAB is as follows. For m is equal to 1 is to j, for n is equal to 1 is to k. Now this j and k are some random numbers, say 10, 100, 20, anything. There will be some statements here. These two values will be taken of j and k, and then accordingly these statements inside will be executed. If it is true, this loop will continue. Once the statement gets false, it will come out of the loop. So that's how you can use a nested for. You can see here there are two for statements used. One for inside the other for statement. So that's the nested for statement. Next we'll see the syntax for a nested while loop statement in MATLAB. That means there will be one while loop inside the other while loop. So we'll have while a particular expression and then another while there will be another expression. When these two are taken into consideration, some statements will be executed. If it is true, this while loop will continue. If it is false, it will come out of the loop. So now this is an example that we have. We are going to use nested for to display all the prime numbers from 1 to 100. So this is the code which is written here. I'll explain you in MATLAB itself. Let's copy and paste this in MATLAB. New script, paste it, save as A5. You can use any name for saving it. I'm using just random numbers in continuation. So when I run A5 now, let's see what's the result that we obtain. These are all the prime numbers between 1 to 100. Now let's read the code. For I is 2 to 100. So from 2 up to 100 is all the numbers included in this variable I. For j is equal to 2 is to 100. So we can take any one number at a time. For example, at the start I is 2, j is 2. We enter the loop. If this is the modulus, which means it will divide and give the remainder as the value. So when you divide two numbers, you should get some remainder and that is the value. Now look here, if factor found not prime, which means first two numbers are 2 and 2. There is no factor of 2 except 1. So it will come out from this statement. It will come to this if statement. This value of j is 2. It is greater than 2 by 2, 1. Since it is true, the value will be printed over here. Percentage D means the number. Currently, the value is 2. So, 2 is a prime number. And the number over here is I. You can see alphabet. So, it is indicating which value of I is being used currently. It is 2. So, 2 is prime. Next, it has come out of the loop. So, it will go back to the for statement. Now, I is 2 and next value of j is 3. So here between 2 and 3, there is no factors found. So we will come here. 3 is greater than 2 by 3, which is true. So you can print the number 3 as prime. Next we will go back to I, which is still 2. And here j has now gone to 4. So when you come here and you find the factor between 2 and 4, yes, there is a common factor 2. And hence, you will not come to this statement at all. You will directly come out of this end statement now. Now, since you have come out of this end statement, the value of I will increment to 3. So when I value increments to 3, this value will now increment to 5. 4 is done. So it will increment to 5. So when you come here, between 3 and 5, there is no common factor. So it will come here. This value is 5 and this ratio is 3 by 5. It's obviously greater, so the number is prime. Next, it will come out of this end loop, but not out of this end loop. So after this, when it goes back to this value of j, it is 6. I was already 3. So 3 and 6. There is a common factor. Hence, this will break and you will directly come out of this end statement. And now the I value will increment to 4. And this value will increment to 7. Again, when you compare 4 and 7, there is no factor found. So you come to this place. You find that 7 is greater than 4 by 7. Hence, it is a prime number. It has come out of this loop. So the value of I is still 4. This value is 8. 4 and 8, there is a common factor. It will break out of the statement. I will increment to 5. This will be incrementing to 9. And accordingly, this is going to continue. So that's how this program runs, and that's how you solve for a nested for loop. Now suppose if you want to find prime numbers between 1 to 50. So let's suppose I change this to 50. So now let's run A5 again. You will find prime numbers between 1 to 50 only by changing this value to 50. If you want to find between 1 to 150, you can change this to 150. If you want to make it between 1 to 200, you can change this number to 200. So that's how this works. So with this, I end the session on nested statements of MATLAB. I hope you have understood how to use the nested statement. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.